In this video, we'll be looking at reaction rate. Now, chemical reactions are something we've been talking about in class and looking at in previous videos. And chemical reactions are happening all around us. So when you cook food, it is undergoing a chemical reaction. There's a chemical change that's happening. You can't reverse that food to its uncooked state after it has been cooked. You have chemical reactions that are happening in your body when you're digesting food. So you have enzymes in your saliva which speed up the digestive process, and then it goes down to your stomach acid to keep breaking down the food. So there's lots of chemical reactions around us in our everyday lives. Now, some of these reactions are slow, like rusting, while others occur really quickly. So there's a picture here of an explosion happening. This reaction happens very fast, and it can produce a large amount of heat, light, and sound. So it's a reaction. There's new chemicals produced down here, but what's actually happening is a lot of energy is being released because it's a very fast reaction. So the speed of a reaction, when we refer to its speed, we are talking about its reaction rate. And there's a great video for you to watch here on nitrogen triiodide, which is a touch explosive or contact explosive, very, very reactive. There's another video that you can have a look at describing reaction rates and how they can be increased. So I would like you to watch that and take some notes. And now we'll look at some specifics. So this one here, this is surface area. So this is a way that we can increase a chemical reaction. So make it go faster. So more reactants can interact when particles are small. So if I have two different substances here, the green and the grey, if they're smaller, what that actually means is that there's more surface to the volume. So if you look at the two sides here, the volume is the same. So the same amount of stuff is there, but by having them smaller, you've got more surfaces. And by having more surfaces, you've got more chance for chemicals to collide with each other and react. So large particles have less total surface area. So remember, it's the same amount of stuff, but because they're larger in volume, their surface area is smaller to their volume, and your reaction is not going to be as fast. So there's a couple of examples we can look at for this. So if I'm I'm out camping and I've got a fire and I want it to start going really fast because I'm cold, if I break down the sticks or have smaller pieces, it will burn faster. It will react because burning a log is a chemical reaction. So if I break that log down into smaller pieces, it will react faster than if I try and just burn a couple of really big logs. Because if I have it broken down, there's more surface in contact with the flame that's already there, with oxygen, and it will react faster. Another example is when we take tablets. So some tablets you'll take, they might have like a coating on the outside, and you take one solid tablet. Now that tablet will probably be one that dissolves in your body over time and it releases the medicine through the day. Whereas if you have a capsule, if you ever see a capsule, when you take the outside off it, it's got powdered tablet inside, and what happens is the outer coating will dissolve, and then you've got all these smaller pieces of the tablet which will dissolve into your system much quicker. Or if you've got aspirin, so aspirin dissolves in water, and by dissolving it you go from having one big tablet to it broken down into really, really small pieces, and that will get into your body faster when you swallow it. So increasing surface area will increase reaction rate. Another way to increase reaction rate is increase the concentration. So quite often when we're doing chemical reactions, we use hydrochloric acid, and you will have noticed that we will have things from 0.1 molar to 1 molar or 2 molar hydrochloric acid. And what that means is we are increasing the amount of acid that's in the solution. And by increasing the concentration, you're increasing the chance of collision. So if you have fewer particles, they are less likely to collide. Then if you increase the concentration, you are more likely to have collisions and a reaction take place. We talked about in year 7 when you were learning about different types of solutions, and concentration and saturated solutions and things like that, that you could buy things like concentrated cordial that you add to water, and if you like it quite weak, you just add a little bit into the water, and if you like it quite strong, you add a lot of cordial into the water. So concentration If you increase the concentration, you'll increase the reaction rate. Now there's a great infographic here that I would like you to go through and then basically take some notes so that you can describe these different types of rates of reaction and how we can increase rate of reaction or decrease it. So the first thing to understand, like I've been talking about, collision theory. So collisions are really important in chemical reactions. So collision theory states that for a reaction to occur, particles must collide with the correct orientation and with sufficient energy. So what this means is particles aren't just going to touch each other and necessarily chemically react and bond together. They need to collide with the right orientation and energy. So often by increasing the chance of that happening, you're going to increase the chance of a reaction taking place. And there's different ways that we do that. So one of the ways, as I mentioned before, concentration. If you increase the concentration of particles available to react, you increase the frequency of possible collisions. So by having more of a certain particle in a reaction, you're increasing the chance of them colliding. So increasing concentration, on the other hand, you could decrease the concentration to make the reaction happen slower. Pressure. If you remember last year, we had things, I think we might have even done it this year, where we get out the plastic syringes and you put your finger on the end and you can press down on the plunger and you can compress the oxygen and the gases, the air that's inside the syringe. And the same thing can be done if you're wanting a chemical reaction to happen. If you compress gases and have the particles closer together. So this isn't about increasing concentration. This is the same amount of chemical, but by compressing it down, so this is with gases, if I compress it down, it's more likely to collide because I'm squeezing it down into a smaller space. So the same amount of stuff, but now in a smaller space. So compression or pressure, pushing things closer together, can increase reaction rate. The other method we've talked about a little bit is increasing temperature. So if I increase the temperature, I'm increasing the kinetic energy. So kinetic energy is movement, so moving, and by increasing this, I'm increasing the frequency of collisions. All right, so I'm increasing the energy for those particles by adding some heat in, and the likelihood of them colliding and reacting increases. So catalysts, like I said before, you've got catalysts in your saliva. Catalysts speed up reactions, okay, by lowering the activation energy required. So catalysts are really cool because what they're put into chemical reactions to increase the reaction, but they're not actually used up themselves. So they go in and they increase the reaction, but they don't get used up. So enzymes are protein molecules that act as catalysts in the reaction of living organisms, so enzymes, but there's other catalysts we can add to things. Like I said, you'll have detergent at home that will say things like has a catalyst added, and catalysts speed up reactions but don't get used up themselves. And as we mentioned before, increasing the surface area of a solid increases the number of particles that are exposed, which again can increase the frequency of collisions. So you can see here you've got one big cube versus that same cube cut up into smaller pieces. You've now got way more surfaces that can come into contact with each other. So the last thing here, we've got some more information from our textbook, and there's some questions at the bottom of the page here that you can complete.